All right, now that we've calculated our sampling distribution and we know what the distribution is, we know what the parameters are of the distribution, let's go back to our research and null hypothesis. Our research hypothesis designated H1 and our null hypothesis designated H0. So, the null hypothesis states that there is no real difference between the sample means. Remember what that means, the sample means. In any experiment, we have at least two groups, at least two sample means, a control mean and an experimental mean. If we're doing an expansor on cancer and we're trying to create a drug that reduces cancer, if this is our control group, this is the mean of the control group, the group that did not get any of the fancy drug X cancer treatment, we want our experimental mean to be over here somewhere. We want it to be less than the control. We want the mean of the tumor that we're measuring to be smaller in the cancer treatment group. I hope you can understand that. So here's our two means. We have one mean here, and if the other mean falls over here, the experimental mean, that's not very impressive. That's within the normal range of fluctuation, normal range of variability. If it falls over here, that's not very impressive, right? It has to fall way over here to be considered a rare occurrence. This is all common occurrence. This is rare according to science. So when the experimental mean falls way over here and the control mean is here, that's when we can claim to have statistical significance. And we say that the probability of error is very low. Now, anytime you get a difference, it could exist for one of two reasons. One, it could be real. The independent variable really did drive that difference in a dependent variable. This cancer drug really does work. Or the second option, unfortunately, is we could have made a mistake somewhere down the line. The results are due to error involved in sampling or some other means. And there are two ways of describing the error that can occur. There's what's called a type 1 error, is when you reject the null hypothesis, claim something is significant when it really isn't. This is called a false positive also. And a type 2 error is when you fail to reject the null hypothesis. You claim something wasn't significant when it really was. So this is called a false negative. The probability of committing this type 1 error is called alpha. Alpha is set at 0.05 for science, generally, widely accepted by most scientists. The null hypothesis then can be rejected if there is less than 0.05 probability of committing a type 1 error. Here's 0.05 in one tail. I hope you can see that this is the same thing I said up here, just with kind of a different set of statistical words. If the experimental mean falls into this tail, basically we can say with confidence that the probability of error is less than 0.05. So you can have it all in one tail like this, an upper tail like this is important to you, or you can split the difference and have half of alpha in each of the tails.